Chapter 7, Section 1, Part 2. Today, we're going to be plugging numbers in, substituting in to find the value of the expression that they give us. Okay, so now wherever I see an S, I'm going to be plugging in a 2. And wherever I see a T, I'm going to be plugging in a -3. All right, so remember that it's easiest to tell where things go if you put substituted numbers in parentheses. The first thing I want to do, however, is rearrange. Okay, I know that I have some negative exponents that need to move elsewhere. So I'm going to keep my 3s to the third on the top, but that t to the second should go on the bottom. Second thing I'm going to do is substitute. Okay, so that means on the top I have 3 times 2 to the third. On the bottom I have -3 to the second. Okay, if I'm following order of operations, I have to do my exponents first. So I will be left with 3 times 8. And on the bottom, I have a 9. Then I'm going to multiply to get 24 over 9. All right, letter A. Remember that for all of these, any place that I see an N, we'll put a -2, and a W, we'll put a 5. But the first thing we need to do is rearrange. So I have W to the 0 on top, N to the 4th on the bottom. W to the 0, or anything to the 0 power, is just 1, so I'm not going to bother with that. But my N is a -2 to the 4th power. -2 to the 4th power is 16, so I have a 1 over 16. Okay, rearranging letter B is going to keep the W to the second on the bottom, but move the N to the first on the bottom, meaning I'm going to have to put a 1 on top, so it's not empty. W is a 5, so I have 5 to the second power times the N to the first power. 5 to the second power is 25 times -2 to the first power is -2. And then 25 times -2 is -50. Okay, letter C, we have another number to the 0 power, so I know I have a 1 on top, W to the 6th on the bottom. W is a 5. 5 to the 6th power happens to be a big number, 15,625. Okay, and last but not least on this page, the 1 stays where it is, the N stays where it is, but the W to the first comes up to the top. So W is 5 to the first power, N is -2. 5 to the first power is just 5 times 1, still just 5 over -2. You're welcome to leave it like that, or you could turn it into a mixed number. All right, a population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. Evaluate the expression for h equals 0 and h equals -3. What does each value of the expression represent in the situation? So this is telling us that we need to solve this 2 times. We're going to solve it with 0 as my h, which means the first right away, and -3 as my h, which happens to be 3 hours before. Okay, so we're going to plug those in. 1,000 times 2 to the 0 power gives me 1,000 times 1, since anything to the 0 power is 1, tells me 1,000. Okay, the second answer we're looking for is 1,000 times 2 to the -3rd power. Okay, meaning I have to turn that into 1,000 times 1 over 2 to the 3rd power, or 1,000 times 1 to the 8th, or 1 over 8, sorry. Okay, and if I take 1,000 times 1 over 8, I get 125. Those are the two answers they're looking for in this word problem. All right, last but not least, a population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the W, where W is the number of weeks after the population was measured. Evaluate the expression for W equals -2, W equals 0, and W equals 1. Okay, meaning 2 weeks before they measured, right when they measured, and 1 week later. Okay, so our first is going to look like this. 5,400 times 3 to the first power, which gives us 5,400 times 3. Which is 16,200. That actually was the last one written on there, so I apologize for doing those backwards. Then let's go with W to the 0 power. So 5,400 times 3 to the 0 power. Remember that anything to the 0 power is just 1. So it's 5,400 times 1, which gives us a population of 5,400. And last but not least, before they even started counting, 5,400 times 3 to the -2 power, which is 5,400 times 1 over 3 to the second power, or 1 over 9, which is actually equal to 600. All right, that is the end of this lesson. You should be able to complete the assignment, which is on page 417, numbers 10 through 44 even, 45, 46, and the lesson quiz.